In this video, I'll be going through the solution to the 2025 Australian Mathematics Competition Upper Primary Paper, question 28. So, in this question, they say that a grid is sparse if in every 2 by 2 subgrid there is one black square and three white squares. How many 4 by 4 sparse grids are there? So to approach this kind of question, the first thing to do is just to try and find some sparse grids. So the first thing to notice is just look at the middle subsquare. This is a 2 by 2 subsquare, which means exactly one of the four squares in the middle must be black and the other three are white. So let's assume that this square on the top left here is black. And since only one square in each 2 by 2 subgrid is black, these must be white. So I'm going to denote this with a cross. And now, look at the top left subgrid. We already have one black square, so these squares must also be white. Now we look at the top middle subgrid over here. We already have one black square, so this must be white. And then we look at this subgrid here on the middle on the left, and this must also be white. So as long as we choose this square to be black, all these squares around it must all be white. Now, we found the color of 9 of the 16 squares. Let's take a look at the others. So now, if we take a look at this top right subgrid over here, we can see that we have two choices. We either color this black and this white, or we color this one black and this one white in order to have exactly one black square in the top right subgrid. Now, if we come back to this case and look at this subgrid on the far right, we have three white squares, which means this square is forced to be black. And now we can take a look at this square over here. On the bottom. So because the bottom right subgrid over here, it already has a black square. It means that these two must also be white. Now we take a look at this subgrid in the middle on the bottom. We already have three white squares. That means this square here must be black. Now we look at the bottom left subgrid, we already have a black square, and this must be white, and we found the only possibility for this case. And if this happens to be the case, let's take a look at what happens. Again, we focus on the subgrid on the right in the middle, because this square is black, this must be white. Now, we can take a look at the bottom right subgrid. These two are white, so which one is black? We have a choice. We can either make this black and this white, or we can make this white and this black. Now, we look at this case and look at the bottom middle subgrid. We already have a black square here, so this one must be white. And now we look at the bottom left, we have three white squares, which means this square must be black. And similarly, we can go to this subgrid here And we see that we have three white squares, so this one must be black. And on the bottom left, we already have a black square, so this one must be white. And we have found all the solutions for this square being black. So this square, if this square is black, we have three grids. However, at the beginning, we have chosen arbitrarily for this square to be black. At the start, I said that this middle subgrid in here must have exactly one black square, and we chose the top left to be our black square. But we didn't have to choose the top left. We had a choice. We could have chosen one of these four squares, and each one of these four squares we choose, it's going to similarly lead to three solutions. And since there are four squares I could choose at the beginning, and each one has three solutions, it implies that the total number of sparse 4 by 4 grids is 12. And we are done.